Section 0. Overview. Welcome to the R3S Modeler Life Foundation course. This course is designed so that delegates watching these videos can follow the trainer step by step. This course is designed for R3S Modeler versions 4.2 and above. Users must have version 4.2 or above installed to participate in this course. Material for this course can be found on the RNA Analytics Support portal. Please download the materials for this course before watching these videos. The Life Foundation training course is aimed at new R3S Modeler users or users with limited modeler experience who will be actively using the system and developing models. This course provides a firm foundation for modeling in Modeler by covering the main components of the system in detail. Following the course, you will be able to use and develop code in the system for company-specific products. The content of this course will consist of building a simple model, including a couple of liability programs, by adding modules for different types of calculations, covering duration and probabilities, cash flows for different types of benefits, expenses and premiums. Throughout the different sections, we will also cover the main concepts of modeling in Modeler, like the use of events and rollback variables, as well as some of the functionalities of the tool, like the analyzer and the compare page. Section 1.0 – Files and folders needed. You should have now downloaded the Life Foundation course from the RNA Analytics Support portal and saved the zip on your desktop. Go to the zip folder and extract the contents of the zip file to your desktop. Open the folder. The zip file contains two subfolders: Workspaces. This is where the workspaces, data files, and output templates which we will use during this course are located. Documentation. This includes the delegate binder, which is the manual to be used during the course and which includes explanations on some of the main R3S components and concepts alongside the exercises which will be presented in this course. Other documents are also included, like the course overview and the prerequisite course quiz. The Workspaces folder includes two subfolders: Life Foundation Start Point. This is where the start point files are stored, which are the ones that the user needs to use to start the course. Stage Workspaces. This is where the workspaces corresponding to the different stages during the course are located, in case the user needs to use them at any intermediate stage during the course, including the endpoint workspace and related files. The Life Foundation Start Point folder contains the following files: Stage 1. Life Foundation Start Point.wvu. This is the Start Point workspace we will be working on in this course. Error Trapping Exercise.wvu. This is a workspace containing a model whose components have been modified on purpose so it generates runtime errors when the model is executed, which will be used during the troubleshooting exercise. Overview.wvu. This is an overview workspace containing some pre-configured modules we will use throughout the course. Revenue Account Start Point.xlsx. This is an output template we will use to export our model results to. During the process of creating our model, we will be updating this file to show our model results. The Data folder. This folder contains data we will be using in the model we will build. eadata.csv. This file contains example endowment assurance data saved in the CSV format. tadata.csv. This file contains example term assurance data saved in the CSV format. eadatabase.xlsx. This file contains example endowment assurance data saved in the XLSX format. Section 2.0, R3S Introduction, General Overview. This presentation provides an overview of the fundamentals, along with background on the design of the system. R3S Modeler is a calculation engine designed to enable users to build detailed structures, calculations, and interactions required in today's financial environment. It is open and flexible, allowing it to be adapted and enhanced through development and configuration to meet the client's key areas of focus. We provide clients with a range of vendor-maintained standard code libraries covering liabilities, assets, and regulatory requirements, enabling rapid implementation and further development. This includes complex concepts such as ALM, stochastic processing, and multi-layered interactions of individual records, as well as aggregated elements, all inbuilt to the structure of the models. The R3S suite also includes a production environment called R3S Workflow Manager, which is a web-based platform that manages model executions, adding integration capabilities to deliver a fully orchestrated end-to-end actuarial workflow. R3S Workflow Manager provides security, audit, and governance functionalities to meet enterprise compliance requirements such as IFRS 17, Solvency II, or ICS, including a dashboard module for reporting purposes that allows direct access to the model results. R3S Workflow Manager serves as a dedicated production environment with a user-friendly interface that can also be operated through external API calls, ensuring optimized efficiency through automated workflows. R3S Development Manager allows several users to work in the same R3S modeler environment. Since it is common for users to be working on different aspects of the same model, for instance, a user building code, whilst another user is building the related data and assumptions. This reduces the task of merging workspaces. The check-in, check-out functionality ensures only one user at a time can be working on a component within a sandbox. This provides a consistent view on which components users are working on. A copy of the user's sandbox is continuously backed up on a server, providing security in the event of a crash. Finally, it provides end-to-end audit from model development through to model output. With regard to regulation, R3S Modeler enables users to comply with external regulatory requirements by producing the required information at the appropriate level of detail, undertake all calculations, stresses, and scenarios to satisfy the regulatory environment you operate in, Complete production-level calculations with the required security, robust governance, and audit trail reports. In the context of risk management, undertake extensive calculations, modeling your portfolio of assets and liabilities in a manner the company wants. Project both sides of the balance sheet in the same model, incorporating realistic time and data-sensitive dynamic decisions. Automatically calculate key metrics on a range of scenarios and stresses on a regular basis. Complete ad hoc investigations in response to internal and external situations. For reporting purposes, produce values to be exported to a range of reporting or BI interfaces used by the company. Allow drill down from the final numbers to the underlying data to understand the impacts of data and parameters. Automatically produce a range of reports to be accessed by all levels within the company, from management to analysts. The regulatory environment can change quite quickly and give rise to new modeling requirements. R3S Modeler is a system that is flexible enough to incorporate whatever the regulation requires. For example, Solvency II capital-based regulations and IFRS 17 accounting standards. The system design is therefore focused on flexibility, taking a modular approach where code can be written separately and bolted together and interchanged very easily. This also means that complex code can be broken down into manageable blocks to be linked together. The system has a modern interface, and there is a visual model builder to help you build models which reflect your company's structure. R3S Modeler's main components. The model serves as the central framework linking all components. In the example shown, the top layer, PVFP, calls a reserving projection from the reserve layer, which performs the reserve calculation. The reserve itself is calculated through a dedicated projection within the reserving layer. The possibility of having separate layers makes Modeler very flexible, as we can separate out calculations into different projection layers. The layout of the data is specified in a data view or database view. The data process tells Modeler where your data files are located and which layout to use. We write code, usually to carry out various cash flow projections. The user can write code in neat modules that fit together. These modules are then combined to form a whole program in the projection process. The assumptions to be used during the projection are specified in assumption sets and may be read in from an external source if required. Section 2.1. R3S Introduction, Workflow and Module Focus. R3S Modeler is a cash flow projection system, which is usually used for projecting cash flows into the future. Modeler can process cash flows in two main ways. There is a third way, called group by group, but this would only be used in very specific circumstances. Record by record processing. It may be that the runs can be processed without the need for global decisions. For example, if all the assumptions to be made about the future can be decided before the projection starts, then policies can be processed record by record. Therefore, all the cash flows are projected for a particular record until the end of its life. Then all the cash flows for the next record are projected to the end of its life, and so on. Modeler will assess the best way to project data, either on a record-by-record basis or on a step-by-step basis. When there are no interactions between programs, record-by-record processing is used as it is faster. When there are program-to-program interactions, such as in ALM modeling, step-by-step processing is automatically used, as shown in this example. A cash flow model must project forward liability records, asset holdings, and company decisions such as bonus payments across future time periods. Then, all the data needs to be read in at the valuation date for all assets and liabilities. All of the data gets passed into the projection layers, and all records are projected forward for one time step. The results are passed up to the parent program, used to calculate decision rules. Results of the decisions then get passed back down, and the assets and liabilities get revalued. For example, the amount of bonds to sell depending on the equity value, etc. With profit bonuses are also calculated using decision rules in this manner. All records then move forward to the next step, and the process is repeated. This is done for all the time steps in the projection. Looking at Modeler's interface, there are four main parts. In the top left corner, the Workspace Explorer. In the bottom left corner, the Properties panel. On the right, there is the Chooser panel with three different tabs: Variables, Components, and Functions. And finally, the central window in the center of the screen. Focusing on the Workspace Explorer, this shows all of Modeler's components which exist in the workspace, like modules, projection processes, etc. This is what the model looks like in the system. We observe first in this example the data layer, where the data is read from the external data source. We then have a realistic layer which contains the realistic projection with the relevant assumptions. Next, there is a separate reserving and market value projection to calculate the reserve and asset prices. So each of these layers contains a projection process, and these can reflect the company's actual structure. This is a program. Inside this program contains several modules. Each module contains variables and associated calculations focused on aspects of the projection, like duration and probabilities, or death benefit cash flows. Within the modules, there exists different tabs in addition to the usual forward time step calculations, or step variables, depending on the type of calculation that is required. This provides the flexibility needed for all possible calculations. All use similar syntax and approach for consistency and transparency. Events are time-dependent substeps which occur based on a date formula, usually depending on record attributes. It caters for multiple cash flows between the steps. For example, premiums or annuity payments. It also allows for one-off yearly cash flows. For example, taxes or bonus payments. Loops are iterative calculations ending when a predetermined condition is met. Multiple loops can be defined within a single model. The Rollback tab allows for backward time step calculations which are started once the full forward projection is complete. This is usually used for discounting cash flows to calculate present values. We saw earlier a much simpler example of a projection process with two non-profit programs feeding into a non-profit fund. However, other programs and funds can be added to model the whole company, as in this example. For each projection process which is attached to a layer, we can link programs together to reflect a company's group structure. Each program here contains the relevant code, but the visual representation allows us to see how the calculation process flows between programs. To summarize, there is complete flexibility in the construction of layers. We can fit calculations together very easily. The models can reflect a company's group structure depending on clients' needs. The design is such that all the layers can be run stochastically. This means that we can run nested stochastic calculations. This allows for complete flexibility in cash flow projections, allowing users to model whatever is required for reporting and regulatory purposes. Section 3.0 Life Prerequisite Course Summary. Let's open the workspace Stage 1, Life Foundation Start Point. This is the same workspace as the Endpoint workspace from the Life Prerequisite course. Open the workspace by clicking twice on the .wvu file in the Life Foundation Start Point folder. Open the company monthly model and go to the data process. Expand the data layer and double-click on the data process, company data. In the data source within the data process, we see the following properties. Input source. It could use either a data view or database view. Since the input file used is a comma-delimited file, we selected the Data View option. Data View defines the Data View component to use for each data source. Data File indicates the location of the data file. Filter formula. If this is populated, only the filtered policies will be passed down to the main calculation layer. Record identifier. It points to the variable used as the unique record identifier for each record, which in this case is the variable policy number. Record start date and record end date. These properties are used to indicate which variables represents the start date and the end date for the projection of each record. In case you don't see any of these properties within the grid, you can right-click on the header of the data source grid and select Field Chooser. You can then drag and drop the hidden field to the grid and then click on Save Settings. This allows you to see this property the next time you open this type of component. Open the Data View, EA Data View. Go to the Variables tab and sort the Data View variables by formula in ascending order. This was created in the prerequisite course and includes a mix of variables reading from the data file and others with formulae to derive required values from the information included in the data file. Below the data layer is the realistic layer, which serves as the main projection layer. This is where the projection process is attached to the model. Double-click on the projection process Realistic Projection Monthly. This takes us to the canvas where we find the endowment program named NP-End. Click on the drop-down on the program. This shows the program contains the product module Endowment NP Monthly. Double-click on the module Endowment NP Monthly and go to the Step tab. This takes us to the variables that sit within the module. These variables calculate the probabilities and durations added during the prerequisite course. Go back to the company monthly model, expand the realistic layer and click on Runtime Settings. Go to the Properties tab. Here we observe the following properties. Projection step lengths. Here we state the required calculation step length. In this case, it has been set to monthly, but this could also be annually or a combination of both. For instance, monthly for the first 3 years, then annually thereafter. Modeler will take longer to run if shorter projection steps are applied. Recalculation steps. This is only applicable in the case of a sublayer and states how frequently the sublayer needs to be called from the main layer. Start date. The date on which the layer projection begins. End date. If this is left blank, the model end date will be used as the layer end date, and the model will project the calculation up to this point as a maximum. Now go to the Programs tab. Here we find the following properties. Assumption set. Realistic assumptions is applied here. This was created in the prerequisite course. Aggregation report. This is the output report which contains the variables to be output from the model. Go back to the model. This is currently a single layered model. During this course, we will add a sublayer to calculate the reserves by using discounted cash flows. Go to the Properties tab. Here we observe the following model properties. Portfolio date. This is the model start date when the model projection starts. Model end date. This is when the model projection ends. Section 3.1, Prerequisite Quiz. This quiz tests delegates' understanding of the content covered during the Life Prerequisite course. Open the file R3S Life Prerequisite Quiz.pdf in the subfolder 2, Delegate Handouts under the Documentation folder. Try answering all the questions within the quiz. it is recommended that you have the prerequisite endpoint workspace open while looking at the different questions. Complete solutions are provided in the next video. Section 3.2, Prerequisite Quiz Solutions. These are the solutions to the prerequisite quiz. Pause the video to double-check your entries and go to the prerequisite endpoint workspace to see the relevant components in the model. Question number 1. Which view would you use to define the structure of a text file? To define the layout of a text file in R3S Modeler, users need to use a data view component, rather than a database view. Question number 2. In which R3S Modeler component would you specify the record identifier? The record identifier is defined as a property of the data source within the data process. Question number 3. Which variable in the data view or database view did you use the mid function in the formula? The mid function was used to define the variable product code. Question number 4. Which component would you specify the location of the data file? This can be done in the data source properties within the data process. When reading a text file, this is defined in the data file property. Question number 5. What is a global property of a variable, and give an example of one? A global property refers to those properties which apply everywhere that variable is referenced in the workspace. Examples of this are the properties data type, portfolio, and aggregates. Question number 6. What is a local property of a component, and give an example of one? A local property refers to those properties which apply only to the component where that variable exists in. For instance, any variable can have a different formula defined in components like a database view or a program. Question number 7. What is the necessary syntax to use when specifying a date in a model, for example, 31/12/2017? To define a hard-coded date value in a model, users need to apply a hashtag before after the date. Question number 8. If you open a new R3S Modeler workspace, which life tables are provided within the system? None, as no components exist in a brand new workspace. Where can you get more life tables from? Users can get most common life tables used in different markets worldwide through the RNA Analytics website. Under Home, Knowledge Base, Resources, Life Tables. Question number 9. In the prerequisite course, we defined premium modal in the data view, which has the data type set to numeric, but its aggregate property set to no. What is the reason for this? The reason for setting the aggregates property for this variable to no is that it is nonsensical to sum premium modals for different data records, as some policies may pay premiums at different intervals, like monthly or yearly. Question number 10. When running a model, what are the different run types? Models can be run in live, filtered sample, sample all, or profile mode. Question number 11. What function did you use to calculate the age at the inception date? To calculate the variable age in the data view, EA data view, we used the function duration. Question number 12. Where in your model would you add the assumption set you intend on using in a layer? To attach the assumption set for a layer, users need to expand the layer and click on the Runtime Settings button. Once in the layer, the assumption set can be attached at layer level from the Properties panel, or at program level in the Program Property Assumption Set. Question number 13. Other than the Workspace Explorer, where else can you access all the components in your workspace? All the components existing in the current workspace can be accessed via the Chooser in the Components tab, which is on the right-hand side of the screen. Question number 14. In which component and which section do you specify the database connection string? To tell R3S Modeler where the data file is located, depending on whether a data view or a database view is used, this can be done in the data source properties. Data file or database connection string in the data process. Users can also define the database view property, database connection string, to locate the columns to be read for each variable. Question number 15. If you added a variable to your aggregation output report with its aggregate property set to no and run the model, what figure would R3S Modeler output in the results dump for that variable? Values in the aggregation report for a variable whose aggregates property is set to no will show the figure for the first record processed by the model. Note, due to multi-threading processing, this value would not necessarily be the first record in the data. Question number 16. Name two types of output report. You can specify an output report in the aggregation report, grouped report, individual report, or record report properties of a program in a layer. Question number 17. Name a component where you would initialize a value for a variable. Users can initialize a value for a variable in a data view or database view, an assumption set, or an initialization module. Question number 18. If you want to obtain a value from a variable which is an array, which modeler function could you use? Users can use the lookup function for obtaining values from an array variable.